We're going to explore the role of probiotics in gut health and how you can use probiotics as a clinical tool for your patients and your clients. I am a member of the clinical education team at Diagnostic Solutions Laboratory. I myself am very passionate about gut health, and in clinical consults, when we're looking at the GI map, I get a lot of questions about probiotics. So I'm excited to dive into this topic with you all today. Our learning objectives, we are going to define what probiotics are and understand their fundamental characteristics. We'll understand the concept of strain specificity. And then throughout, we're going to explore how you can leverage the GI map to select effective probiotics for your patients. All right, so first, let's define what are probiotics. So in 2002, the United Nations Food and Agriculture Organization and the World Health Organization put together a working group to really come up with a definition as well as some guidelines around using probiotics specifically in food products. So, this definition was later supported by the International Scientific Association for Probiotics and Prebiotics. And the definition is live microorganisms, which, when administered in adequate amounts, confer a health benefit on the host. So, a couple of key pieces here with this definition. First, we want probiotics to confer a health benefit. There's lots of microorganisms out there. Not all are helpful for our health. And so we definitely want to see that beneficial effect. And then another key feature I'll point out here is when administered in adequate amounts. So we want to make sure that when patients are using a supplement, they're using maybe a food product that contains probiotic strains, they're getting a therapeutic dose so that the probiotics are able to confer and elicit that health benefit. When we think of when we might use probiotics, there's a lot of different conditions, there's a lot of different research on the applications. Of course, we think about gastrointestinal imbalances. That makes sense. Lots of different ways that we can use probiotics to support gut health. So, ranging from irritable bowel syndrome, inflammatory bowel disease, GERD, constipation, diarrhea. But then the research is continuing to expand on a lot of different ways that we can go beyond the gut and consider how the gut interacts with other organs and other systems throughout the body. So we can think about more novel applications using probiotics for skin conditions, for example, psychobiotics, looking at the gut brain axis, using probiotics for patients with anxiety or depression, even metabolic health. So, this is just a kind of starter list, certainly not exhaustive, lots of different ways that we can apply probiotics for clinical practice. So, now looking at some key characteristics of probiotics, again, lots of microorganisms out there, but they don't all meet the requirements to be considered a probiotic. So, some of the things that we're looking for, we want to make sure probiotics are able to resist the harsh conditions of the GI tract. We're going to dive into this in more detail in just a second, but think about stomach acid, digestive enzymes, bile. There's a lot to contend with. We want to make sure probiotics are able to adhere to the mucus or epithelial cells within the gut. This helps them to persist for a period of time so that they're able to confer their health benefits. And we want probiotics to have antimicrobial activity. This is going to be a big topic that we'll talk about today, especially when we think about pathogens and opportunistic microbes that we see on the GI map. And probiotics can use a number of different methods to have antimicrobial activity to really support the immune system against pathogens. And again, we're going to dive deep into that today. As part of that, probiotics can have an immunomodulatory effect. So, of course, support against pathogens, but also helping with immune modulation, with inflammation. And then finally, we want to make sure probiotics are safe for use. So, some things to consider when it comes to safety. We want to make sure that a probiotic product does not contain pathogenic organisms. There isn't a risk of antibiotic resistance or transferring antibiotic resistance genes. Considering side effects, typically when a patient's taking probiotics, especially if they're from reputable companies, manufacturing practices, all of that is really high quality. Patients might experience maybe some minor side effects, some bloating, some gas, especially when they first start using a product. But we want to make sure that companies we're using are using clinically studied species or strains. I will note in terms of safety, there is some research on yeast probiotics. There may be some contraindications for severely immunocompromised individuals. So, if we look at survival challenges in the gut, again, a lot that probiotics need to contend with, starting off with stomach acid. So, this by its very nature is meant to reduce the survival of microbes, but this applies to probiotics too. Pepsin can also negatively impact protein structures on bacteria, which can make it harder for probiotics to adhere to the cellular layer. That's one of the main characteristics we want to see. And some probiotics have strategies in place to help to increase their survivability through the stomach. So, for example, lactobacillus and bifidobacterium will use exopolysaccharides to create almost like a biofilm protective layer around them so that they are able to survive in those harsh gastric conditions. And then spore based probiotics, they enter the body, they're in a spore state, and that enhances survival. Once they reach the small intestine, they're able to germinate. Speaking of the small intestine, so once probiotics make it through that acidic pH of the stomach, they do encounter a more favorable pH in the small intestine. But then they have to encounter bile acids and pancreatic enzymes, which again can impact their cell structure. Once they reach the colon, this is where the majority of our commensal microbiome is housed. They have to contend with those commensal bacteria for adhesion sites. They compete for nutrients. So, a lot goes into being able to survive and persist within the GI tract. In terms of manufacturing practices, this is a huge topic, can get very complicated. So, I'm going to keep it very high level today. But a few things to consider: enteric coated capsules can help to enhance survival rates. We want to think about requirements for storage of probiotic products. So, some will require refrigeration, for example, while others are stable at room temperature. Refrigeration obviously can limit portability. We run the risk of, when they're being transported, maybe some of the quantity of probiotics that are in a product might diminish. And again, we want to make sure that when the patient is taking a probiotic, they're getting that therapeutic dose. And just overall considering shelf life. So, not only thinking about how many CFUs are present at the time of manufacture, but shelf life, stability over time. Again, by the time that patient's taking the product, we want those health benefits. So, getting into mechanisms of action, just high level, and then we'll get a little bit more specific. But there's a lot of different benefits and ways that probiotics can interact with our body, with our microbiome. So, they produce secondary metabolites such as short chain fatty acids, enzymes, vitamins. These metabolites can be helpful for a whole host of reasons. And some can help to reduce the luminal pH, which can be helpful for pathogen inhibition. Certain metabolites can also support the microbiome, so they act to cross feed, or basically, if we look at our own innate flora, certain metabolites can serve as a fuel for those microbes. Probiotics can exert a number of antimicrobial effects, as I mentioned already. So, looking at reducing pH, they can produce a number of antibacterial substances. They compete for space. So, this is called competitive exclusion. They can support our barrier function. This is really important as well in keep maintaining space between pathogens. And then, of course, our lamina propria and systemic bloodstream. Probiotics can also help to regulate motility and modify bile acid metabolism. So, if we look at the illustration on the right, we see our barrier. We see that one cell thick layer, epithelium, and then the green mucosal layer on top. That creates that barrier, that buffer between our lamina propria and the intestinal tract. So, when we have any sort of diminishment in the mucus, or if we have any damage to the epithelial layer, maybe hyperpermeability, or what we refer to as leaky gut, that's when endotoxins, inflammatory cytokines can get through into the lamina propria into the bloodstream, we can have the immune and inflammatory effects. And so, really important that we maintain the integrity of that barrier. Looking at the immune system in a little bit more detail here, probiotics can interact with our immune system in a variety of ways. They can activate pattern recognition receptors on epithelial cells, promote T cell differentiation, and activate Treg cells, which helps to maintain homeostasis in the mucosa. They can help to induce B cell maturation, and the B cells produce immunoglobulins such as secretory IgA. Probiotics interact with a variety of immune cells, including macrophages and dendritic cells, which play important roles in identifying and eliminating pathogens. Probiotics can help to modulate cytokines, so both inflammatory and anti inflammatory, working on that immune balance. And we talked a little bit already about some of the direct actions they can have against pathogens. So, again, competing for space or that competitive exclusion, secreting antimicrobial peptides, working on that barrier integrity. So, this is a nice illustration on the right that just goes through some of these concepts, a nice visual summary of many of the different ways that we're seeing that immune function and pathogen inhibition. All right, so we've talked already about we want to make sure that probiotics are able to adhere to the mucus or the epithelial cells. We want to make sure they're able to persist in the gut for a period of time so that they can confer their health benefits. But something that we want to think about is whether these effects are a little bit more transient or whether there's ongoing colonization. And a lot of the research points more towards a transient effect, where probiotics may persist in the gut for a period, maybe several days, weeks, maybe longer, but not so much research on permanent colonization. Few strains are able to recolonize. I would love to see more research on that, but the research I found points more to transient effects. So when we think about using probiotics to replenish or reinoculate the gut, unfortunately might not be quite as simple as that. And we can use this concept to guide clinical recommendations in terms of thinking, okay, how long am I going to recommend that a patient takes a certain probiotic? So, some examples of strains that have been found to persist in the gut. Again, we want that, but it is more temporary. Lactobacillus rhamnosus GG has been found to persist for at least 1 week after consumption. And we'll go through this strain in more detail in just a moment here. Another Lactobacillus rhamnosus strain in just a small study, so looking at 10 subjects. While subjects were supplementing with this strain, it was found to be dominant in about 6 out of 10. But then 2 months after discontinuing the supplement, this strain was only detected in 1 out of the 10 subjects. So again, it did have more of that transient effect. Lactobacillus casei shirota, which we'll talk about in greater detail today as well. In a study of 25 healthy adults, it was found in stool of 3 of those adults 7 days after supplementation, and it did persist for up to 14 days after discontinuing. So even though the patients weren't actively taking the product, there was a little bit of persistence past that. Another study looking at 25 samples found this Lactobacillus casei shirota strain in 1 out of 25, 28 days after the discontinuation of supplementation. But then researchers looked at the recovery rates between days 7 and 14, and that did vary widely. And something that I found in doing research for this presentation was that sometimes the effects of probiotics can be individual. The health of our microbiome, genetics, that can vary, influence how certain strains might interact with our body. So again, when we think of functional integrative medicine, we want to consider each patient standing in front of us. And then finally, just to drive this point home, Saccharomyces boulardii was found to clear out of the body about 2 to 5 days after discontinuing supplementation. All right, so let's go ahead and get into the topic now of strain specificity. Again, I first learned about this from Dr. Jason Harlach. So if we think about taxonomy, we have different categories in which we organize organisms, starting from very broad and then becoming much more specific. So at the phylum level, for example, on GI map, we're looking at bacteroids and firmicutes. These are big categories. From there, we start to narrow. We can look at class, order, family, genus. So, in terms of probiotics, some examples at the genus level are Lactobacillus and Bifidobacterium. And some characteristics of probiotics are shared at that genus level. Then we move down to species. So, examples here, I have a couple on the slide. So, Lactobacillus rhamnosus versus Lactobacillus acidophilus, two different species. And again, some characteristics are shared at the species level. A lot of research is done at the species level, but then we do have an opportunity to get even more precise by considering strains. So there can be a lot of different strains within the same species, and some benefits and some characteristics are different from strain to strain within the same species. So, again, a lot of research that we have is at that species level. Some probiotic products will list species. But one of the challenges with that is we don't always know which strains are in that species. And so it can make it a little bit challenging to take the research and apply it into clinical practice. Sometimes, if we're looking at different products that have the same species, but a patient might notice different effects, potentially they have different strains within that species. So, again, today we're going to explore some benefits at that species level, but just know there is that opportunity to get that much more advanced and specific by considering the strains. So, here in these top two lines, you can see an example of two different strains within the same species. So, we have Lactobacillus rhamnosus GG, and then we have Lactobacillus rhamnosus 299V. And they can have different characteristics, different applications for clinical practice. Looking at this systematic review and meta analysis exploring the efficacy of strain specificity, they reference a study in which 127 different lactobacillus strains were screened, and they found that only 3% met the criteria to be considered a probiotic. So they based this on survival to the target organ and the ability to resist bile and stomach acid. And then they go on to reference a investigation of 170 species of lactobacillus. And they found, even at that species level, significant variation in sensitivity to antibiotics and the ability to act as a probiotic. They go on to say the presence or absence of different factors by different strains may also explain why some probiotics are effective in some diseases, yet not effective in a different type of disease. So, when we think about strain specificity and using specific strains for clinical practice, step one is to think, why do I even want to use a probiotic? What are the specific symptoms or conditions or disease that I am wanting to address and support with the use of probiotics? And knowing that why, knowing the objective, can really help guide your recommendations. From there, ideally, you're choosing a strain that has been clinically studied and shows benefit for that specific symptom or disease. We want to be careful about extrapolating results from one patient population to another or one disease to another. A couple more studies just to highlight this concept. On the left of this study was looking at different strains within Bacillus, Lactobacillus, and Saccharomyces. And they found that at the strain level, there were differences in how probiotics were using carbohydrates and how they tolerated environmental stressors. So, again, acidity, antibiotics. And then the study on the right was looking at different strains within Lactobacillus plantarum, so within the same species, and their ability to produce extracellular polysaccharides, which can have interactions with our immune system. In this study, they found that there were strain-specific impacts of these extracellular polysaccharides, and that did impact immunomodulatory properties. So again, just to illustrate, we want to think about strains. We can get much more specific when we're looking at strains versus species level. Now, moving into different types of probiotics, we can consider traditional probiotics. These have been very well studied, very well applied and used in practice. So Lactobacillus, Bifidobacterium, and then Saccharomyces variety Boulardii. A lot of people refer to this as Saccharomyces boulardii. It has undergone a name change. I will probably say Saccharomyces boulardii just for time's sake today, but no, that's the full name. We have spore-based probiotics, so these are bacillus. And then we have this category of next generation as well as precision probiotics. And this is really the next wave of probiotics and using probiotics. So, next generation, I have a couple of examples there. Some are still in research, some are on the market, like Akkermansia muciniphila. But we're really looking at the unique benefits that they can have. A lot are present in our microbiome. We can use them for barrier integrity, metabolic disorders, and neurological conditions. And then we have this idea of precision probiotics. So, this is looking at using specific strains that are maybe tailored to an individual's microbiome or genetics. So, rather than this one size fits all, really getting precise one on one precision medicine and thinking about it a little bit more in kind of a pharmaceutical or medical context. All right, so to get into the traditional probiotics first, we're going to go through some properties that are shared at the genus level, just talking about lactobacillus generally, then some examples at the species level, and then just a few examples of strains. So, lactobacillus, gram positive, a couple of species that you might see in probiotic supplements, things like L. acidophilus, L. plantarum, L. casei, L. reuteri. Lactobacillus produce lactic acid from carbohydrates. This helps to create a more acidic environment, which is helpful for pathogen inhibition. Some lactobacillus can produce bacterial metabolites, so things like bacteriocins, which help to prevent pathogen growth. At a genus level, they do possess mucus binding proteins. And then they also can produce cell surface pili. And there can be differences there at the species level that helps to promote mucus binding. So they're like appendages that help them to bind onto that mucus. Some examples of benefits at the species level. So just to highlight a few, Lactobacillus acidophilus has been shown to increase short chain fatty acid levels. Those are postbiotics. And then Lactobacillus reuteri has antimicrobial effects against H. pylori. So it can help to reduce the overall bacterial load of H. pylori. It can increase mucin secretion, and it can also help to reduce side effects from antibiotic treatment, as well as improving GI symptoms. So, to get into a few specific strains, first we have Lactobacillus rhamnosus GG. This is a very widely studied and very widely used strain. There's a lot of research out there. This strain is resistant to stomach acid and bile, which is good. We want to make sure it makes its way to the colon. It's very good at adhering to the epithelial layer, to the mucosa layer, especially when we compare it to other lactobacillus strains. And we see that it does persist in that descending colon. So, again, able to make it through the GI tract. There's a number of benefits to this strain. It can prevent cytokine-induced apoptosis of epithelial cells, can help to modulate inflammation. It can support barrier integrity, which again, super, super important. There's some positive effects for irritable bowel syndrome. In a study looking at the infant gut, it was shown to increase bifidobacterium. So this is a nice example of maybe we're not using a probiotic to directly reinoculate the gut, so not giving bifidobacterium to increase bifido in the gut, but rather using a strain to help our own innate flora to flourish. Lactobacillus rhamnosus GG can also be helpful in preventing GI infections and diarrhea. There's a number of pathogens and opportunistic microbes on the GI map that we could consider. So things like Salmonella, Pseudomonas, Staphylococcus, Streptococcus, Enterococcus faecalis, and Enterococcus faecium. Lactobacillus rhamnosus GG and Enterococcus faecium have very similar pili that they use to bind onto that mucus. And so they can compete in that way. And then this strain also can promote macrophage activity against Enterococcus faecium. Just a few more examples of lactobacillus strains. So looking at Lactobacillus rhamnosus 299V, it's been shown to improve symptoms of IBS. It also can help support barrier integrity, can reduce that hyperpermeability or leaky gut. It can exert anti-cytotoxic effects, which helps with inflammation. In a study of patients with depression, it has been shown to improve cognitive performance. So, again, if we're thinking of gut brain axis, more novel approaches to using probiotics, good example there. And it's also been shown to increase short chain fatty acid concentrations in patients with C. diff. Lactobacillus casei shirota, we explored a little bit earlier its ability to persist within the gut. It has some beneficial effects for rheumatoid arthritis. It can also help to decrease the duration of norovirus gastroenteritis. In a study of healthy medical students, so they didn't have any big medical conditions, but they were taking a big board exam. So, under a lot of stress, when they took this Lactobacillus casei shirota strain, it helped to improve the alpha diversity within their microbiome. Other research shows that this strain can be helpful in improving bowel movements and decreasing bacterial load of C. diff. And then it can also help to alleviate constipation while impacting our microbiota. So increasing Bacteroidetes and Firmicutes while decreasing Bacteroidetes and Roseburia while decreasing Firmicutes. And in that particular study, it also helped to regulate bowel movements. It helped to soften hard stool and vice versa. Moving on to bifidobacteria. This is gram-positive, lots of species out there. Some common species you might see in probiotic supplements: B. adelentis, B. bifida, B. breve, B. long. A lot of times we'll see B. lactis, but this has also undergone a name change. So B. animale subspecies lactis, a bit of a tongue twister there. So, bifidobacterium can produce exopolysaccharides on their outer surface layer. We mentioned before, those polysaccharides can provide a barrier, like a biofilm, to protect against acid, but they can also help to influence our commensal microbiota. So, in vitro studies have shown that Bacteroides fragilis and Faecalibacterium prausnitzii, for example, can modify metabolism when they encounter these exopolysaccharides. Bifidobacterium can produce a number of metabolites that are useful for pathogen inhibition. So things like organic acids, bacteriocins. They use quorum sensing, which is basically their ability to send and receive signals to coordinate. So they'll use this communication to coordinate and regulate the release of these compounds. And then they metabolize complex carbohydrates to produce short chain fatty acids via what's called the bifidobacterium shunt. They also have surface pili, so similar to lactobacillus. This helps them to adhere in the gut. And the bifidobacterium shunt and mucus binding proteins are shared and similar at that genus level, but only some species have that cell surface pili. So again, looking at how we can get benefits at genus level, get a little bit more specific at species level, and then even more specific at strain level, which we'll get into some examples of some strains. And as I mentioned earlier, there is some research showing that differences in a patient's microbiome, how one person can differ to another, that might contribute to some of these different responses in how bifidobacterium are interacting and exerting their effects. Just a couple of examples: Bifidobacterium animalis subspecies lactis BB12. Again, quite a mouthful. This strain has been shown to help reduce IBS symptoms, antibiotic associated diarrhea. It can help to prevent GI infections. In one study combining this strain with another strain, these two together were shown to increase bifidobacterium levels and support barrier function. Another study looking at, again, BB12, but combining it this time with Lactobacillus acidophilus LA5, helped to improve glucose tolerance. So just a couple examples there of, again, different applications and different combinations and synergistic effects between different strains. This strain has also been shown to support H. pylori eradication and can help to support secretory IgA levels, which are important for that immune response in the gut. Same species, different strains. So looking at the HN019 strain, this can be supportive of immune function. It can improve functional GI symptoms, so things like constipation, irregular bowel movements. It's been shown to help improve transit time. In pediatrics, research showing that it can help reduce diarrhea. And then again, looking at how we can combine strains. So combining 8019 with lacti casei bacillus rhamnosus HN001 helped to relieve functional constipation. And researchers found that patients that had constipation tended to have higher levels of 5-hydroxytryptamine. And these two probiotics, one of the proposed mechanisms is that they help to reduce the level of that neurotransmitter. Looking now at Boulardi, again, not the full name, but I'm just going to shorten it here. So it's really good at having stability against acid and bile. It's able to withstand a wide range of temperature levels. So that's also really important when, again, we're thinking of shelf life and stability over time. It does demonstrate epithelial adherence. It can be resistant to antibiotics. So we'll explore how we might use it for patients who are taking an antibiotic. It can help to modulate the microbiome in terms of stimulating short chain fatty acid producing microbes. And then it can also have a protective effect for our commensal microbes. Interestingly, it tends to be larger in size compared to some other probiotics. And this surface area really helps with its ability to bind directly onto pathogenic bacteria. It can upregulate the secretion of secretory IgA, decrease side effects, and support antibiotic therapy for H. pylori. And then finally, at the species level, has been shown to increase lactobacillus and bifidobacterium. Now, getting into a specific strain here, the CNCMI745 strain. This strain has also been very well studied. There's a lot of research out there on it. Also good at surviving acid and bile. It's able to reach the colon. It can reach stable levels pretty quickly within 3 days of taking the product. And so that's really great, especially for patients that might be on an antibiotic. We want those health benefits to be reached in a pretty quick amount of time. But then it does clear out of the body fairly quickly as well after discontinuing use. This particular strain has been shown to be beneficial against a number of different microbes. I've listed some that you'll find on the GI map. And we're going to go into some of these in a little bit greater detail. Also helps with the secretion of secretory IgA for immune response. Some other benefits here. So in patients with idiopathic diarrhea, it was found that they can have a thicker mucosal layer. And we want balance within the gut. That's not necessarily more is not necessarily better. And so this particular strain helped to kind of balance things out. So it decreased acromegaly, reduced the thickness of the mucosal layer, and then helped to increase Bacteroides and Roseburia. It can be helpful in supporting the microbiome after diarrhea or antibiotic use. And then a number of other benefits in terms of barrier integrity, anti-inflammatory effects. So again, lots of different applications to consider here. In terms of its antimicrobial properties for E. coli and Salmonella, it's able to bind directly onto the pathogen. There's a number of different ways that it supports immune defense. It can help to maintain barrier integrity during infection. And then with Salmonella, it can modify the motility of Salmonella and decrease the invasiveness. For C. diff, this strain has been very well studied for its benefits against C. diff. It can have direct action against toxin A and toxin B. So it helps to inhibit the ability to bind onto the receptors, and it can also degrade toxins. It has some anti-inflammatory effects and can help to decrease the recurrence of C. diff infection. Looking at Candida, number of different ways that this strain can impact Candida's growth. So inhibiting filamentation, biofilm formation. It can produce capric acid, which reduces virulence. It's anti-inflammatory. And then we get to H. pylori. So similar to a lot of these other microbes, this strain can help to prevent H. pylori from binding onto duodenal cells. It can reduce colonization of H. pylori. And then it also produces a number of substances that have direct action against H. pylori. So it's addressing H. pylori from a number of different angles. And as I mentioned, we might consider its use during antibiotic therapy. So these two papers, they didn't specify the strain, but I just wanted to keep everything together. So here we're talking more at the species level. But one study looked at combining Saccharomyces boulardii with quadruple therapy for 14 days. This wasn't a statistically significant improvement, but we can see the percent of eradication in the probiotic group was slightly better than no probiotic group. However, symptom improvement was statistically significant. So we see in this study a 78.6% symptom improvement. in the group that was given the probiotic and the quadruple therapy versus a 58.3% symptom improvement in the group that did not receive the probiotic. A systematic review and meta analysis, again, not specifying the strain, but just looking at Saccharomyces boulardii with the use of quadruple therapy, similar percentages in terms of that eradication, but they also found that the probiotic helped to significantly lower adverse effects, which, is important for compliance and also quality of life during therapy. And when we think of antibiotics just in general, so not specific to H. pylori, as I mentioned, Saccharomyces boulardii, and now here getting again specific to this CN-CM I745 strain, it's not affected by antibiotics. And so it can be helpful for preventing antibiotic associated symptoms and providing a little bit of support and protection for that microbiome. So, in a mouse model with amoxicillin, using this strain, it was found to help restore the microbiome back to its pre antibiotic state. So, 10 days versus took 22 days in the untreated group. And during this time, it also was found to help increase the alpha diversity in the gut. Researchers extended probiotics for 7 days after the course of antibiotics, and they found that this helped to get the microbiota kind of back to its initial balance. In a separate study looking at patients that were treated with metronidazole and Cipro, this particular strain helped to increase species that were impacted by antibiotics. So again, can have that support for our microbiome. And moving into spore-based strains, we're not going to spend as much time on these today. We're going to be a little bit more general here. But Bacillus probiotics, so they have that spore that protects them from the stomach acid. It can be resistant to heat, which is really helpful for transport and storage. Again, thinking about shelf life here. And once those spores reach the intestinal tract, they germinate, they're able to confer their benefits. So they've been shown to help increase short chain fatty acid producing bacteria, as well as increase bifidobacterium. One study looking at 5 very specific strains in an ex vivo model found some modulation in the gut. So Akkermansia, Mucinophila, and Firmicutes were increased. And then they did see a decrease in Lactobacillus and Bacteroidetes. There's research looking at bacillus probiotics and their ability to impact certain opportunistic microbes that we see on the GI map. So things like Klebsiella, Citrobacter, Pseudomonas, Escherichia, and Staphylococcus aureus. One of the ways that they're beneficial against Staphylococcus aureus is they impact that quorum sensing. So again, how bacteria are communicating with one another. One specific species, so looking at Bacillus subtilis, it was found to inhibit Enterococcus faecalis. And then there's a few strains that have been studied for their benefits in improving IBS symptoms. And finally here, we're just going to touch on Akkermansia muciniphila briefly. Again, this is part of that group of next generation probiotics. So Akkermansia muciniphila uses mucin as a carbon and nitrogen source. This is really beneficial when nutrients are scarce in the gut. Again, the bacteria within our gut or microbes within the gut are competing for nutrients. And so this is one advantage. They also help to support mucosal layer integrity. Muciniphila means mucin loving. They can also exert some antimicrobial effects. And part of how they do this is they promote differentiation of Paneth cells and goblet cells. So the goblet cells release or produce mucus, and then the Paneth cells produce antimicrobial peptides. They also have an outer membrane protein, which interacts with toll-like receptor 2, and this helps to support barrier function and decrease inflammation. So just to summarize here, if we zoom out and think about how we might use the GI map to help guide probiotic supplement recommendations, a couple of themes that we've talked about in today's class. So looking at antimicrobial effects, again, GI map is looking at a number of different pathogenic and opportunistic microbe targets. So using probiotics more for that. We want to support the immune system, supporting secretory IgA. So a few strains to consider there. Looking to modulate the microbiome. So page 2 of the GI map, we're looking at commensal and keystone bacteria and ways that we can support the health of our commensal flora. And then finally, considering the importance of barrier integrity, making sure that we're supporting the mucus layer as well as that epithelial layer. And then, if we think about using probiotics in clinical practice, we've talked very specifically just about probiotics, but I think it's important to zoom out and consider how we can use them as part of a comprehensive protocol, maybe bringing some other tools on board. There can be synergistic effects as well, especially when we're thinking of ways to support our commensal flora. So, just a couple resources and final thoughts to leave you with. So, we do have in our DSL Academy, which is an online learning platform, we have a course that goes through common dysbiosis patterns that can be seen on the GI map. And this includes an insufficiency pattern, so when commensals are low, as well as an inflammatory pattern when we might see pathogens, as well as inflammatory microbes. So that gives you a little bit more if you want to dive deeper into some microbial patterns you might see. As a reminder, when we're thinking about using probiotic strains, we really want to match condition and symptom with the appropriate probiotic. This might mean using one strain, or it might mean using a couple different strains. Some products will have just one strain in there, others will have a collection. And so I always encourage practitioners, if there's a particular product you're wanting to use and you want to learn more, reach out to your local rep for support, get those questions answered. When we think about comprehensive support for the commensal flora, it can be helpful to think of the 4 Ps, which is yes, using probiotics, but also thinking about how can we use things like polyphenols, prebiotics, postbiotics, which are metabolites produced by bacteria. A combination of these can really help with not only the efficacy of probiotics, but also just, again, giving a little bit more of that support so that our commensal can flourish. And in terms of prebiotics, we do have a nice handout in our DSL resource library, just on our main website, on different fibers to consider when we're looking to impact specific commensals. All right. And with that, I want to thank you all so much for joining me today. This is a big topic. There's a lot of different strains to consider for clinical practice, but hopefully this gave you some direction and some ideas for how you can begin to apply this concept and use probiotics in clinical practice to enhance your outcomes with your patients.
Welcome to Rupa Health, the best place to order, manage, and track results from over 30 different lab companies in one single place for free. It's going to take you under 2 minutes to sign up, and you can order any functional medicine lab for your client in under 30 seconds. Let me show you how it's done. So here's our beautiful interface. I'm typing in the name of my client, selecting the lab that I want to order for them, and hitting send. From there, Rupa and their amazing team handle the rest. They email the client, collect payment, and even offer an interest-free 3-month payment plan. We've also built the world's largest library of information about chronic health conditions, the lab tests that can help you find the root cause, and the evidence-based interventions that you can use to help people heal from them. It's called the Rupa Health Magazine. There, we have in-depth articles about almost any health condition you can imagine. And we give you step-by-step protocols that other clinicians have used to help their clients heal and that are verified by evidence-based sources. You should totally check it out, and it'll transform your practice. And we can't wait to see you. So make sure you sign up today at rupahealth.com.